Hello, today we are going to learn to use apply function in R. This function is a part of apply family which consists of sapply, lapply, vapply and tapply. So let's look at the documentation to understand where we can use this function. Usually apply function is used to apply over matrix. You can apply this function row wise or column wise using the margin argument. Margin argument of 1 means you want to apply the function row wise, and margin argument of 2, it means that you want to apply the function column wise. And finally the fun is the function which you want to apply. Let's take an example so that it will be more clear what I mean to say. So let's take a matrix which goes from 1 to 9 with 3 columns. So this is how the matrix looks. Now let's say we want to find maximum in each row. Okay, so this is one row, the maximum is 7 here. This is another row, maximum is 8. This third row, maximum is 9. So we want to find maximum in each row. So how do we apply the apply function? Use apply, the name of the matrix, which is mat. Now we want to apply it row wise. So for row, the margin argument should be 1 and then the function name. So here we want to find the max. So the function for that is max. So once you apply this, you get 7, 8 and 9. So in first row, 7 is the maximum value. In second row, 8 is the maximum value. And in the third row, 9 is the maximum value. Similarly, you can also apply it column wise by just changing the margin argument to 2, and now it gives you 3, 6 and 9. Here in first column, the maximum value is 3. In second column, the maximum value is 6, and in third column, the maximum value is 9. Just to take another example, we can also find sum of each row. So let's do sum. Sorry, this is for columns. So this will give you sum column wise because we have used margin argument 2. That's why. So 1 plus 2 plus 3 is 6. Then 4 plus 5 plus 6 is 15. And 7 plus 8 plus 9 is 24. And same goes with row wise as well. 1 plus 4 plus 7 is 12, 2 plus 5 plus 8 is 15, and similarly for the third row. Obviously, this was just an example, and if you want to find sum, there are always functions like row sum and col sums, which will give you the same, but this was just an example to make you understand how you can use the apply function. Sometimes you need a customized function and need something more than the inbuilt functions like sum and max. In such cases, you can use anonymous functions to work with apply. So let's say you want to take sum of difference of each value in row and then return the absolute value of it. So what I mean by that is you want to take difference of each element with its previous element. So let's say 4 minus 1 and then 7 minus 4, and then return the absolute value of some of these differences. So for this case, 4 minus 1 is 3, 7 minus 4 is again 3, and take the sum of it, which is 6, and return the absolute value. So in this case, we do not have an inbuilt function which does the same immediately. Like we need to write a function using few of these inbuilt functions to get what we want. So in that case, we can use anonymous function in this way. So first argument is the matrix on which we want to apply the function. One margin is to specify that we want to apply this function row wise, and now we use customized anonymous function x. So here we do first take the difference Yeah. So def function gives you the difference. So for example, def 235 gives you 1 and 2. So that basically means 3 minus 2 is 1, 5 minus 3 is 2. So it gives the difference. Then you want to take sum of it and then return the absolute value. So this gives 666. So 4 minus 1 is 3, 7 minus 4 is 3, and sum of it is 6, and the absolute value is 6 again. So it goes same for all the rows. If we do column, we get 2, 2, 2. Like, because 3 minus 2 is 1 and 2 minus 1 is 1, and sum of it is 2. That's why. Here x is the row value, and using diff, it first takes difference between the values, then takes sum over it, and finally returns the absolute value. X is just a variable name, and you can use any variable you want. So let's say use p. It's still fine. It will give you the same answer. You can use even your name. It's still fine. So it's just a placeholder. It's just a variable which you use. As mentioned earlier, apply function is more suitable to work on matrices. However, it also works on data frames and would give you the same result. So if we convert this matrix to data frame, now we have a data frame, and if we apply the same functions, so instead of mat we apply df, which is data frame, and rowwise, and get the max as the same. So it still works on data frame the same way it works on matrices, but one thing to keep in mind is that although apply works on data frames, internally it still converts it into matrix. So df here still is treated as matrix. This is how apply works, and you can use customized functions, anonymous functions to make it work on your data frames or matrix. Okay, now I'm going to show you an interesting example. I have this vectors 1 0 1 na x2, which is 1 1 x3, you can see 1 2 4 x4 a b c and d. Now I create two data frames. First data frame would have variables x1, x2, x3, whereas second data frame would have the same, but except it would also have 4 with it. So oops. So this is that one, this is that two. So both are same, only the difference is that two has an extra column with values a, b, c and d. Now let's say I want to find number of ones in each column for both the data frame. So how do we get that? Like, how many number of ones do I have? So here we have in x1 column we have 1 and 2 1. Here we have 1, 2 and 3 ones, and here we have in x3 we only have 1 1. So to do that, how do we use the apply function? Say apply that one. Now we want the number of ones column wise, so we use margin 2. And now let's use anonymous function. So what do we want to find? Some number of ones. Let's take sum of it. This will give us number of ones, but since we have NAs in each of them, Let's just ignore NA. Okay, yes, this makes sense. X1 column has 2 ones, X2 column has 3 ones, and X3 column has 1. Okay. Now let's use the same function for dat2. Oops. Why did it give all zeros? We just added one column, right, with A, B, C, and D. One would expect that it should give the same answer as the previous one for all the columns and just return 0 for X4 column, since it does not have any value of 1. So why did it change all the values instead of changing only X4 value? I was expecting that it would give us the same values 2, 3 and 1, and for X4 it would return as 0, but instead it just gave all the values as 0. Okay, think about it. The answer to this I'll give it in next video.